number one defining and enabling material of the modern world. There's a reason we make something like 3 billion tons of concrete per year as a species. It's because nothing else gives us the utility, gives us the use, gives us the function that you get from concrete, and in particular reinforced concrete. So in that sense, it literally and figuratively underpins the modern urban world. It's the most important material we manufacture.
It's not recyclable. Recycling means if you have something like a wood, if you let it go, it would actually disintegrate to carbon, oxygen, hydrogen. It really does. At the end of the, let's say 10 years, all organic stuff go back to what they're made of. That's the beauty of evolution. That's it's probably most magnificent thing about the earth, in my opinion, is the evolution and how these things came together, right? That's not in concrete. You cannot recycle concrete. It's a rock. What can you do? You can grind it, make it smaller, which, by the way, that requires a lot of energy. So that's rather dumb to do.
Well, one of the problems for concrete specifically is even if you were to reduce or if you were to replace the fossil fuel energy that's used to manufacture cement, the key ingredient of concrete, with zero carbon sources, you'd still have a large carbon emission, because many of the emissions associated with manufacture of cement, about 60% of them, are associated with the chemistry. You're breaking down limestone into lime and carbon dioxide. So that's a real Achilles heel for concrete, is you've got that chemical set of emissions that can't be mitigated by using low carbon energy sources such as wind or biomass.
They have been working for maybe 100 plus years, mostly doing the same thing, let's be very honest. Mostly. Of course they have research and development, they come up with the stuff, but the gist of it is, imagine if the car was essentially still the Ford. the same, the Model T was a little bit of bells and whistles, but just essentially the Model T. That's really what it is. There is no incentive in America, in England, in France, in Germany to change this, because why? We make it this way, it's not that expensive. So there is some regulation needs to come through the world that say, you can't use concrete in here, at least in this way. You got to use something else.
These kinds of high-performance materials, when they're developed, would have a very important role in, for example, refurbishing existing buildings and existing infrastructure, bridges and what have you, because you can hopefully use a very small amount of high-performance material to add extra strength or extra stiffness or extra robustness to an existing bridge, rather than knock it down and build it out of some new wonder material.
Public needs to understand this material is very energy intensive and is the most used material in the world. It's not like, it has a huge impact.
I don't want to discourage people from, taking their new wonder material and sticking it in concrete. That's lovely, but it doesn't, it's a typical material science approach. Make a new material and go looking for applications. What we should be saying is, what are the problems that we face? Let's design a new material that actually addresses those problems.